Moments and center of mass. Suppose the lamina occupies a region D and has density function rho xy. Recall that we define the moment of a particle about an axis as the product of its mass and its directed distance from the axis. We divide D into small rectangles. We can approximate the moment of our region with respect to the x-axis by taking our rho delta A and multiplying it by some unit or some y, the moment of the entire lamina about the x-axis. So basically, what these ideas are is that I could find either moments in the x-axis or the y-axis, and so what we're doing is we're just going to be taking all of our little rectangles and we're going to find that moment. We're going to rotate it about one of the axes. So if I want to find a moment about the x-axis, so right here, if I want to find a moment about the x-axis, what we're doing is I'm going to go ahead and draw a little xy plane. So let's consider this an xy plane, and so here's our region. I'll do a different color. So here's our region. And I don't have a highlighter, I'm going to highlight. So given our region, if I want to find a moment, about the x-axis, what we're doing is we're rotating this about the x-axis. That means, though, that when we're rotating it, if I'm finding, this x here, what's going to give me that distance is going to be, it's going along the y-axis. And conversely, if I want to rotate this about the x-axis and I take a value, or the y-axis, all right, then again, this would be, say this is x, this is y. Then what I'm going to do is when I rotate this about the y-axis, I'm going to be taking an x value. And so that's why there's an x when we're rotating it about either the y-axis or the x-axis, because that gives me the distance, how far we are along when we rotate. So hopefully that tells you why we have an x and we have a y. So the coordinates x bar, y bar are the center of mass of a lamina occupying the region D and having density function rho of x, y, r. We're just going to take our rotation about y. We're going to divide that by our total mass, and then we're going to get the average. And taking statistics, or if you haven't taken statistics, you know that when you take the average, you're going to find the center of things. So we're taking the average for x and y, and we're going to get the center of mass. And again, we find that by just taking our rotation for x, rotation about y divided by m, and then for y, taking the rotation by x and dividing by m. So you have all those formulas above, and we're just going to use those, and we're going to use integration to find the center of mass, wherever that may be for our lamina. Again, which the lamina is that very, very thin slice of a region, super thin, right? Find the mass and center of mass of the lamina that occupies the region D and has the given density function rho. Alright, so D is the triangular region enclosed by the lines x equals 0, y equals x, and 2x plus y equals 6, rho of x, y equals x squared. Alright, that's good. They give us everything that we need. So the first thing I'm going to do, I'm going to go ahead and draw the region. And what I'm going to do is I'm going to go ahead and, for this equation right here, I'm going to go ahead and solve that and have y is equal to 6 minus 2x. So that tells me that I have a y-intercept I want to try to make this as accurate as possible. So I have a y-intercept of 6. And when x equals 3, that's going to give me 0 for y. So there's that line. just go ahead and do all of them in orange. And then I have y equals x, so y equals x. Is going to be kind of like right there. And then I have x equals 0, which is this vertical line right there. So my region, let's change the region color to get a little bit small. And there's our region. All right. So looking at that, our region is bounded by, and we have two functions. We have y equals 6 minus 2x, y equals x. And then we also have the function, not function, but then we also have from 0 to 2, 2. And again, if you can't tell but based off the graph that is 2, 2 where they intersect, you can set both of these equations equal to each other and solve. All right. Now, let's go ahead and write our double integral. So again, we're doing mass. So the double integral of our region in this case, I'm going to go ahead and do x first because my x are constants from 0 to 2. And then my y, all right, is defined by two functions. I have a top function and I have a bottom function. My top function is going to be 6 minus 2x. And my bottom function is just y equals x. And then I have rho of xy as my function, so x squared, and then dy dx. All right, let's go ahead and evaluate. So I have, let's go ahead and take the integral, so 0 to 2. And we're going to integrate x squared with respect to y, so that's going to be x squared y. From 6 minus 2x to x dx. All right, so now I'm going to go ahead and substitute in for y 6 minus 2x. So I get x squared 6 minus 2x minus, and then I have my x squared again, and then I'm going to plug in x for y dx, and it looks like I'm going to get 6x squared minus 2x cubed minus x cubed, so it should be 6x squared minus 3x cubed. From 0 to 2, 6x squared minus 3x cubed dx. All right, now let's go ahead and integrate that. And we're going to get 2x cubed minus 3/4 x to the 4th. That's an ugly looking 4. And I'm going to go from 0 to 2. And so that's going to give me, plug in the 2. 8 times 2 is 16. Plug in the 2, 16, 4, 4, 12. So 16 minus 12 is just 4. Alright, so there's my mass. Alright, and we want to find the mass and the center of mass. So now let's go ahead and find our center of mass. And so we'll find kappa my. Alright, and we're going to go from 0 to 2. X to 6 minus 2x. And here we're going to plug in, we're rotating, so we're going to add in another x. So it's going to be x times x squared dy dx. And so that's really going to be x cubed. So I'm going to erase that and just make that x cubed dy. And now let's go ahead and integrate it. So go from 0 to 2. And I'm going to have x cubed y, because we're doing it with respect to y, x 6 minus 2x dy dx, sorry, just dx. And so we'll go ahead and work that inside there. we're going to go from 0 to 2, substitute in x cubed 6 minus 2x minus x cubed x dx. And so we have the integral from 0 to 2. Looks like we'll have 6x cubed minus 2x to the fourth minus x to the fourth, so minus 3x to the fourth. So very similar to what we had above, but adding in that new x dx. And again, you can work a lot faster than this. I'm just making sure that you have everything. So let's go ahead and integrate one more time. So it's going to be to the fourth, so 6 over 4, so 3 halves. X to the fourth minus, it's going to be to the fifth now, so 3/5, x to the fifth. And we're going to go from 0 to 2. Alright, plug in that, you get 16 over 2 is 8 times 3. 24 minus 32 times 3, 96 over 5. And subtracting, so I'm going to get 24 over 5. Alright, now we need to find our m sub x. And so again, 0 to 2, x, 6 minus 2x. Now this one's going to be more fun because now we actually have a y, so it's going to be x squared. And we have the y there, dy dx. So now when we integrate this, we're going to have 1/2 y squared x squared from x 6 minus 2x dx. Now let's go ahead and do that. Now I could pull out the x squared in front because they both have an x squared, so I can say, okay, from 0 to 2, x squared, and then we're going to evaluate by putting it in, so 1/2 6 minus 2x squared minus, and then 1/2 x squared. You should have put out the 1/2 as well, but I didn't, so 2x. And then we'll simplify what's inside. When we do that, we're going to get, I'm going to go ahead and pull the 1/2 out. I'm going to pull that all the way out in front so I don't have to deal with that till the very end because they're all going to have a 1/2. And so we multiply, I get 1/2 36 minus 12x, so minus 24x minus 4x squared minus x squared, so it'll be minus 5x squared. They're all going to have that x with it, and so we're going to have 3x to the fourth, so the integral from 0 to 2, 3x to the fourth, and then we had subtraction, so minus, and then so 24x to the third power, and then we had to take care of that 6, so we had 36, you have the x squared out in front, so 36x squared. And all that dx. So we have 1/2, and now we can integrate that, and we're going to get 3/5 x to the fifth minus 6 x to the fourth plus 3 12x cubed 0 to 2. Make sure I did that right. 3/5 x to the fifth minus 6x to the fourth plus 12x cubed 0 to 2. So have the 1/2 out in front. Good. When we do the inside, we're going to get 48 over 5. Alright, so we have the total mass, right? So that mass we said was 4. And then to find the center of mass, we have 24 over 5 divided by 4. And we have 48 over 5 divided by 4. We clean that up, we're going to get 6/5 and 12/5. Alright, and that's how we find the center of mass.